Hi, hello everyone. Welcome to this second PPT. This is why process states that important. I'm Hariharasudan. I'm from the Department of Computer Science with Cybersecurity in the College of Dr. S.N.S. Rajalakshmi College of Arts and Science, Coimbatore. Let's start the session. In the first sheet, why process states are important to Red Hat enterprise. Understanding the process state, it isn't just academic experience. It's a absolute fundamental of efficiency Linux system administration and perhaps most importantly to performance optimization and knowing what is the process is doing in the first step of controlling your system. In the third sheet, we start with system performance. By the important state, you can understand and optimize the CPU utilization and resource management. You gain the instance need of properly management memory and input and output resource. In the second one, troubleshoot. In the third one, troubleshoot. Process states you are your primary clue for identifying and resolving solution and bottled. And last one is system stability, and all the leads to great stability, helping to the prevent crashes and maintaining the maximum uptime in the process state are fundamental for all this administration task, providing critical insights into your system overall health. In the next sheet, we start why or the process state. A quick recap that the process is an engine of running process. The operating system, in the case the Linux kernel, manage the program by moving it through a serial of distinct states. The states determine the process behavior and what resource it's allowed to consume at the given moment. Next one is common state, which will look like at the right now, including new and ready, running and waiting, also called as sleeping, stopping and zombie. Each state tells the different story about the what the process is doing and what is the need. And next one is the need first the sorry new this is the very beginning of the process, begins with creating by the kernel, and system is allocated the resource is it will need like a memory PID. First one is and next one is ready. In the process has every it read to run, but it currently waiting in the queue for turn the CPU. And next, running the kernel. The kernel scheduler that has assigned to uh, to process to CPU, and it is actively executive in the instruction. Next one is waiting. In the waiting or sleeping stage, in the waiting, the process is paused waiting for an input output operating system to complete, like reading and file from disk and file from disk, and waiting for a network packet stopped. The process has been executively suspended by using a user signal. It's hot running, and uh, and and it would be scheduled by running until it's to continue. And last one is zombie. In the zombie, the process enters still execute the process table just for holding its final exit status. And next one, last topic is how process state impact system. First one is running process, and next one is sleeping. Next one is interpreting sleeping, and zombie process. First one is running process. This is one of the active using of CPU. If you have to if you have to main process by running or ready state, they will all complete to CPU time. This leads to high context switching overhead and a high load average, making a entire system feel slow. And next one is sleeping interpretable. In the city sleeping interpretable, this is good state. When a process is sleeping, it will wait for some time, like user input, and the data has been network stock. While it's sleeping, it is not using any CPU cycle, freely up the CPU for other process. This may key to significant multiple task. And next one, interruptible sleep. D state. This is bad state. This process is also waiting for IO, input and output, but it is stuck in a way that cannot be interrupted any, not even a kill signal. The most always caused by problem, which is a slow or falling storage device or network file system. A process stuck in the state D is seriously red flag. And next and last one is zombie process. A few zombie process are zombie farmers are harmless, but it is a poorly written parent program fail or rip. It's a children's or zombie can be accumulate. They didn't CPU, but to contribute the slot in a process ID table. If you can run a PID, no new process can be created on its system, which is critical failure. Next, thank you for watching this video. We will see in next PPT, PPT number 3. Thank you so much.